Hello and welcome. In this video, we will solve the question from a GATE 2025 complex analysis from a topic of a Möbius transformation. So question says, let T be the Möbius transformation that maps the pointers 0, 1 over 2 and 1 and conformally onto the pointers minus 3, infinity and 2 respectively in the extended complex plane. First, we will find the Möbius transformation for these pointers. So we have T of 0 equal to minus 3, T of 1 over 2 which is equal to infinity, and T of 1 that's equal to 2. We know that the Möbius transformation T of Z is equal to AZ plus B CZ plus D. In order to find the Möbius transformation for this, there are two ways. One is to put these values in this expression and find the values for B, D, A and C. And another way is cross ratio. But we will use this method. T of 0 that will be equal to B by D, which imply B is equal to minus 3D, and T of 1 over 2 which will be A by 2 plus B divided by C by 2 plus D, which further equal to A plus 2B and C plus 2D, which imply that C equal to minus 2D, because this will be 0, C plus 2D, A plus 2B will be equal to 0, and we can find the values for C. So T of 1 it will be A plus B divided by C plus D, and instead of B we will write minus 3D, A minus 3D, and instead of C we will write minus 2D plus D, which is equal to 2. So we get A will be equal to D, because minus 3 and that will be the 2D that will be the D. So we have three values. One is B equal to minus 3D, C equal to minus 2D and A equal to D. Now we put these values in this Möbius transformation and we get that T of Z equal to DZ plus, instead of B we will write minus 3D, and instead of C we will write 2DZ plus D. So D will be the common from numerator and denominator. We can get Z minus 3 and minus 2Z plus D. So this will be the Möbius transformation from these pointers. So this is the Möbius transformation. Now we can check maybe it is correct or not. So if Z is 0, so it will be minus 3, that will be the 0. Here is actually the 1. Here is 1, so we can write 1, or we put the 1 by 2, that will be the infinity, because here in the denominator will be 0, and if we put the 1 it will be minus 2 and minus 1, that minus and minus cancel out, here will be the 2. Now come to the another part. If T maps the circle centered at 1 with a radius k onto a straight line given by the equation alpha x plus beta y plus gamma z. So if we have a equations, if we have a transformation from a circle centered at 1 z minus 1 centered at 1 to the radius of k, and there is a transformation to the straight line, and which is given by an equation, this alpha x plus beta y plus gamma. So first, in order to find the expression, we have to first calculate this transformation in terms of z. So how we do it? So it's once again a simple. So as we know that w is equal to t of z, and which is equal to here z minus 3 minus 2 of z plus 1. So we can write it z minus 3, and that will be a w. We will write in order to have no confusion, we will write like this 1 plus minus 2z. So it will be, we have to find the value of z. So w minus 2wz, and let us bring the z to the one side. It will be z plus 2wz, and here will be w plus 3. So z will be common, so that will be w plus 3, and here will be 1 plus 2w. Got it? So we have another value of z, that is this. Now we have find the value of a z, so we will use it here. W plus 3, 1 plus 2w, it's 2 minus 1 equal to k. So we can write it like this. It is 2 and w will be here, that will be 2 minus 2w, it's a w by 1 plus 2w, that's equal to k. So we will write it 2 minus w equal to k 1 plus 2w. Now in terms of x and y, we can write it like this. Instead of w, we will write x plus iota y. So it will be 2 minus x plus iota y equal to k, and here we will write 1 plus 2x plus iota ky. So it will be, so we take a k as common, it's just mod of absolute value. So now it becomes to solve the absolute value, we can write 2 minus x cos square plus y square over the root, and here will be k under root of 1 plus 2x square plus y square. So it will be, to squaring both sides, we get the 2 minus x square from here, 2 minus x square plus y square equal to k square, and that will be 1 plus 2x square, and here will be plus ky square. So we solve it like this. So it will be 4 minus 4x plus x square plus y square k square. It will be 1 plus 4x plus 4x square plus k y square. So it's a k square, sorry, it's a k square. So we can write it 4 minus 4x plus x square plus y square, and that will be k square plus 4k square x plus 4k square x square plus k square and y square. We take this from a one side, so it will be 4 minus 4 will be common, so that will be minus 4 will be common, so because it becomes a minus 4 here, so we write it like this. So we write it like this 1, and here will be, it's a x, we talk about the x, it will be minus k square, and here will be x plus 1 minus 4k square, no, it will be positive here, x square, and plus 1 plus k square, and here will be negative k square y square equal to 0. I hope you have understood it up to this. So 1 plus k square, 1 minus 4k square, and this. So now we compare it to the original equation, that is original equation is here. So what will be the alpha? Alpha will be minus 4 1 plus k square. What will be the beta when we compare the coefficients of a y, x and y? So what will be the beta? So there is no expression or any coefficient of a y here, it is y square, so beta will be 0. And what will be the gamma? Gamma will be the rest part, that is 4, and another is k. So I have forgot to write here, it is minus k square here, and that will be minus k square. Now we have to find the value of a k. In order to find the value of a k, as we don't have any coefficient of a x, if the x square, the coefficient of x square here, this expression have no term with a x square, so it means 1 minus 4x square, 4k square equal to 0, which imply k will be equal to 1 by 2. So now we get the values of another values. So what will be the alpha? Simply alpha will be minus 4 and k square, that will be 1 by 4, it will be 5 by 4. So that will be minus 20 by 4. And what will be the beta? Beta is same. What will be the gamma? Gamma will be, beta will be 0 and gamma will be 4 minus 1 by 4. So it will be 15 over 4. So that will be 15 over 4. So we have now this. Now we solve the last part of this expression. So the last expression of this question, so it will be, it is like this. 2k alpha plus beta plus gamma. It will be 2. What is k? That becomes 1 by 2. It's a numerator part of this. And alpha is minus 20 by 4 plus beta is 0. And what is gamma? Gamma is 15 by 4. So to solve this, it becomes a 5. 2 and 2 cancel out. And here will be minus 20 and here will be 5. 5 by 4. And the denominator will be alpha plus beta minus 2k gamma. It will be, that will be alpha, which is minus 20 by 4. So it will be by 5, but I have kept it so that it will look similar to 15 by 4, and that's a easy technique. So plus beta is 0 minus 2. So it will be 1 by 2 and gamma will be 15 by 4. So 2 and 2 cancel out. So here will be minus 15 and minus 20. It will be minus 35 over 4. And now it will be 2 and 2. So the answer will be 5 over minus here. Okay, here is also a minus, sorry. So minus and minus cancel out. It will be 1 by 7. So the part A is the answer. I hope you have understood it. Thank you.